Hello students of ICSE and IGCSE. Today we will be studying class 9 physics and we will be studying motion in one dimension. Okay, so let us see. If you like the class, you can join me again for the next video. For that you have to subscribe and like and comment also. If you want to have any questions or interactions, you can always do so in the comment section. If you have doubts, please ask in the comment section. Okay, so we can start the class today, physics class 9. Okay, and that is motion in one dimension. Now you may ask me, what is motion in one dimension, sir? What does one dimension means? One dimension means motion in a straight line. Okay, suppose you have seen a graph. Where this is the y-axis, this is the x-axis. The motion will be in a straight line along the x-axis only. Such a motion is called a motion in one dimension. It is also called a motion in a straight line or rectilinear motion. It is also called, write down, rectilinear motion. Okay, so the motion will be in a line along the x-axis only. And suppose there is a turn or a curve in the motion, during the motion, suppose you are going like this and then you have taken a turn. That means there has been some motion along the x-axis and there has been some motion along the y-axis also. So that will be a motion in two dimensions. That is not a rectilinear motion. So in this chapter we are concerned only with motion in one dimension, that is along a straight line. Okay, now that if that is clear to you, next we will come to define what are scalar and vector quantities. That is very necessary before we start the chapter. So let us see what is a scalar and what is a vector quantity. Okay, first of all, write down what is a scalar quantity. Something, write down, a physical quantity which can be defined completely, which can be defined completely by stating only the magnitude. Means what is the magnitude? How much? Okay, how high, how low, whatever that is, that magnitude. Only the magnitude is called a scalar quantity. Let us take some few examples, then it will be clearer to you. For example, write down example: mass of a body, then time, then distance. These are all scalar quantities. If you say, for example, mass, if you say kgs, how many kgs? 2 kgs. So the 2 will be important here. There is no direction involved. Even if you say 2 kgs, we have completely defined the mass of the body. Next, time. Time can be said either in seconds or it can be in hours. So even if we state the time in seconds or in hours, we have defined time completely. No other detail needs to be given. That is the same for distance also. Now let us see what is a scalar quantity. Then you will understand the difference between a vector and a scalar quantity. Okay, now let us come to a vector quantity. What is a vector? Okay, so write down any physical quantity where both the magnitude as well as direction has to be specified is called a vector quantity. I'll explain using a few examples. Okay, just wait for it. First write down this one. Okay, for example, let me tell an example. We are leaving home and you have told your parents that I am going 5 kilometers. Okay, but you have not told them in which direction you are heading. So they will not have any idea about where you have gone, isn't it? You have just told them I'm leaving home and I'm traveling 5 kilometers, but it can be 5 kilometers in the eastern direction and it can be 5 kilometers in the northern direction. So the directions will be completely different from each other and they will have no idea where you have gone. So in such a quantity, you have to explain both the directions. Suppose you have told them I am going 5 kilometers north today. Okay, they will at least have some idea about where you have gone. Suppose this is your house. And you have gone directly 5 kilometers north. This is 5 kilometers. You have gone 5 kilometers north. So the people at home will have some idea at least about where you have gone. Okay, and 5 kilometers east will be this direction. But if you just tell them that I am traveling a distance of 5 kilometers today, they will have no clue about where you have gone. You could have gone south to this place or you could have gone to this place. So if you tell them the direction, they will at least have some idea. Suppose you told them from my house I am going 5 kilometers north today, so they will know you have ended up somewhere over here. That's your location. Okay, in such a quantity where the direction has to be specified is called a vector quantity. Okay, let us explain using an example. Example, displacement. Okay, displacement is a vector quantity. So in this case, if I say I have left home and I have traveled 5 kilometers north, that is displacement then. Okay, 5 kilometers north, because you have stated the direction also. I am traveling 5 kilometers north today from my home. So this will be your displacement. Okay, and displacement is a vector quantity. Understood? Now let me give you another example. Okay, suppose this is your house. Your house is at point A. Okay, you have started from your house in the morning and you have traveled 4 kilometers east. So this is 4 kilometers east. Okay, then after traveling 4 kilometers east, you have traveled 3 kilometers north. Suppose you are traveling 3 kilometers north from this point B. Suppose this is point B. Okay, so finally you ended up at a point. Suppose this point is C. You have ended up at point C. So what is the distance that you have traveled? The distance traveled is the actual path that has been traversed. Okay, so 4 kilometers plus 3 kilometers is the total distance traveled. Here distance is not, the direction is not important. So it was a scalar quantity, distance. So I can write, can't I write? Distance traveled is equal to distance traveled is 4 plus 3 is equal to 7 kilometers. I have traveled a distance of 7 kilometers. But now, if I ask you what is the displacement, what is your displacement? So your displacement, initial position was A and the final position is C. So it is the shortest distance between the initial and the final position. That's called the displacement. Okay. By using Pythagoras theorem, this is a right angle triangle. You can calculate the distance AC. AC will be equal to what? AC square is equal to 4 square plus 3 square. 4 square plus 3 square. So that will give you 16 plus 9 is equal to 25. Therefore, AC is equal to what? AC is equal to 5 kilometers. So what is displacement? Displacement is the distance traveled between the initial and the final position in a straight line. That means, or else you can write the shortest distance between the initial and final position is called the displacement. So what will be displacement? I am writing displacement here. Okay, so displacement is, my displacement is what? A to C. A to C is my displacement. A to C is my displacement. So what is my displacement? I have calculated it. AC is 5 kilometers. So 5 kilometers is my displacement. Or else if you want to define displacement, what will you say? It is the shortest path between the initial and the final position. Okay. Let us write down what is displacement. Let us define displacement now. Now we are in a position to define displacement. Okay. Write down. Displacement, it is the shortest distance between the initial and final position. Shortest distance between the initial and final position. Okay, if that is the case, what is the shortest distance? It is always has to be the distance traveled in a straight line, because we know that the shortest distance between any 2 points is always the straight line joining them, isn't it? It is always the straight line joining the 2 points. That is the shortest possible distance between any 2 points. So my displacement is along this line, and my displacement AC has been calculated to be 5 kilometers, and the direction is given by the direction A to C. This is your displacement, directions displacement. Displacement direction is A to C. Okay. So now you have understood the difference between scalar and vector quantities by using the example of distance as well as displacement. So my distance covered was the actual distance traveled between the two locations. That was what? 4 plus 3. So that is a scalar quantity. Here direction is not important, but in case of displacement, direction is the most important factor. What is the direction that you have traveled? The direction you traveled is from A to C, understood? And that displacement was 5 kilometers. You can take this down. And what was rectilinear motion we discussed in the beginning? That is, motion along a straight line is called rectilinear motion, or motion in one dimension, or linear motion. These are the terms that are used for motion in one dimension. Okay, so now you have got basic idea about a scalar and a vector quantity. Now that you have got this basic idea about a scalar and a vector quantity, क्या करेंगे next? Next we will discuss factors like speed, velocity, displacement, distance traveled, etc. Average velocity, average speed, the distance between the difference between the two we will be discussing. Then the units, both we will do SI units as well as CGSE units. Okay, so continue watching, and if you like it, please like and subscribe the channel. We will be studying about two physical quantities, that is speed and velocity. Speed and velocity. First of all, let us write down speed. Okay, what is speed? Write down speed is the rate of covering distance. That means, or you can say covering distance in unit time. Okay, that unit can be hour, that unit can be second. Okay, so it is that, or I am writing again, it is the distance covered in unit time. So we can write speed as So we can write speed as distance divided by time, isn't it? Distance traveled divided by the time taken. Suppose distance traveled is in meters and the time is in seconds, the unit of speed will come out to be meters per second. That means the distance traveled in 1 second. Clear? Or else, suppose the distance is taken in kilometers and the time is taken in hours, we will get speed, the unit of speed will come out to be kilometers per hour. That means in 1 hour, what is the distance traveled in kilometers? Okay, and speed, as we know, is the actual path traversed by the body. Okay, so for example, let us take the previous example. The previous example, the one we had taken earlier, was someone is traveling from point A to point B. The distance is 4 kilometers, suppose, in a direction east. Then from point B, that person travels vertically northwards. How many kilometers? 3 kilometers. Okay. So by using Pythagoras theorem, you can find the distance AC. Use Pythagoras as we did earlier. Then distance AC will come out to be 5 kilometers. So the body traveled from A to B and then from B to C and finally reached point C. So what was the total distance covered is the total actual path traversed by the body, isn't it? In this case, suppose I am taking the time taken was 2 hours, okay? Time taken to travel from A to C. A to C is 2 hours. That's just an example I am giving. Then what will be the speed? The speed will come out to be total distance traveled, that is 4 kilometers plus 3, 7 kilometers, and the time taken they have said is 2 hours. Okay. So it comes out to be equal to 3.5 kilometers per hour. That is your speed. Okay. Now let us discuss the concept of, hope you are understanding. Okay. Now let us discuss what is velocity. Velocity is defined as the displacement of a body per unit time. Velocity is defined as the displacement of a body. Displacement of a body in unit time. Okay, in unit time. Again, that time can be hours or it can be seconds. Okay. So in this case, we have taken displacement. And what is displacement? Displacement is the shortest path between the initial and final position. Okay, shortest path between the initial and final position. So in this case, initial position was A and final position is C. Okay. So what is the shortest distance between A to C? Let us look here. The shortest distance between A to C, the initial position is A, final position C. So the shortest distance is always the straight line between the 2 points, isn't it? So the actual displacement of the body has been 5 kilometers. Okay, that is the shortest path traveled by the body from the initial point to the final point. So when we are calculating velocity, velocity will be equal to displacement of the body divided by the time taken. Okay, time taken. So time taken to go from A to C was 2 hours, as we have mentioned here in this example. So in this example, the velocity will come out to be 5 kilometers divided by 2 hours. So it is coming out to be 2.5 kilometers per hour. Okay, got it? So hope you have understood the difference between speed and velocity. In case of velocity, we took the shortest path between the initial and the final point. Okay, in this case, displacement, that means direction is important, direction from A to C. But in case of speed, we took the actual path that was traversed straight from A to B and then from B to C. So now you have understood the difference between speed and velocity. Hence, velocity is what? Velocity is a vector quantity because it is displacement by time, and displacement is always in a particular direction. Velocity, hope this is clear to you. Okay, velocity is a vector quantity. Since what? Since displacement is a vector, isn't it? Since displacement is a vector. Okay, and how do we represent the direction from A to C? We will say velocity was, you can write, suppose we are putting an arrow on top of AC, which means from A to C, that was the direction. Velocity in this case came out to be 2.5 kilometers per hour. 2.5 kilometers per hour. And what was the speed? The speed was 3.5 kilometers per hour. Now hope you have understood the difference between speed and velocity. Speed was a scalar quantity, remember, okay, since it was distance by time, distance divided by time taken. Hope I have made myself clear. If you are liking it so far, please subscribe the channel and stay tuned for more. Any doubts you can ask in the comment section. Okay, please like the channel. More such lessons are coming up for all the subjects and all the topics of class 9, 10. Also, it will come up in maths and chemistry too. So please stay subscribed to the channel. Next, let us discuss some terms. First of all, we will discuss what is average velocity, average speed. Write down average speed. What is average speed? Average speed is the, write down, total distance traveled divided by total time taken. That means what? The speed may have been different at different times. Speed was not necessarily uniform. Okay, speed could have been different, but the average speed will be found how? Total distance traveled divided by total time taken. Then next what will come to is uniform speed. What is uniform speed? If a body is traveling with a uniform speed, what does that mean? Write down, uniform speed is equal to, how do we define it? Okay, it is when the body is traveling equal distances in equal intervals of time okay, that is uniform speed. Okay, next let us study what is average velocity. Average speed and uniform speed we have done. Now let us come to average velocity. average velocity of a body is equal to total displacement divided by the time taken. Okay, total time taken, that will give you the average velocity. Okay, and what is uniform velocity? Next is uniform velocity. What is uniform velocity? When the displacement of the body is the same in same intervals of time. Okay, for example, if you want an example, I can tell you, suppose the displacement of the body was 4 meters in 2 seconds, then in the next 2 seconds it has travelled another 4 meters, so the total displacement will be 8 meters. Then again in the next 2 seconds it travels 4 meters again. So we are seeing equal displacement in equal intervals of time. 4 meters it has travelled in every 2 seconds. Such a case will be called a uniform velocity. And finally let us try and understand what is the difference between average speed and average velocity by taking an example. Okay, so I am giving you an example. A person is running around a field. A person is standing at point A and is running around a field. Okay, if I am supposing that the circumference of the field is, write down, circumference of the field is 400 meters. Okay, then suppose the person has travelled once around the field and come back to point A. What is the average speed we will calculate? Okay, suppose the time taken, let us write down, time taken is 80 seconds. Okay, time taken is 80 seconds. In that case, what will be the average speed? Total distance travelled is 400 meters divided by total time will be 80. So average speed, what is average speed coming out to be? Average speed is coming out to be 400 meters divided by 80 seconds. So what am I getting? I am getting average speed is equal to 5 meters per second. Okay, 5 meters per second is my average velocity. Now we will find the average velocity. Okay, the person has gone around the field and come back to the original position. So what is the displacement? Displacement here is 0 because the person has again come back to the original point. So displacement of the body is 0. So what will be the average velocity in this case? In this case, average velocity will be total displacement by total time. So total displacement was 0. There is no displacement because he has come back to the original point. Again, he has not moved from his original point. So the time taken was 80 seconds. Okay, so what am I getting? My average velocity is coming out to be 0. Hence, average velocity can be 0 when average speed is not equal to 0. That is a big what difference we are noting here. Okay, remember the concept. Average velocity of a body can be 0, although the velocity during that time was not 0 and neither was the speed 0. Okay, so this is one important thing you have to try and remember. Then in the next class we will be doing numericals based on what? Motion in one dimension. Okay, there you will understand the application of units also. So please stay tuned to the channel. Okay, next chapter will be coming up soon. That will be on numericals based on motion. Okay, so stay tuned and please subscribe to the channel. Thank you, students.